Good morning, student. So today's session is for ICSE class 10. As you all know that exam is very near. By next 2 months or 3 months, you are having the exam ICSE class 10. So I am starting the sessions for physics, and today I will be discussing about the electricity. So this will be a kind of revision classes for you, and I believe this will really help you, okay, to understand. And also you know that for next 2 3 months during the study, sometimes the effort you are giving, you have to give the perfect effort, okay, the good technical effort, and I will help you to understand how to revise the chapter effectively before exam, okay. So I'll start with the circuit, the very basic circuit. Okay, so this is the circuit. Now I'll be adding two devices. So those are ammeter and one is the voltmeter. Okay. So in a complete circuit, what are the component we have? We are having a voltage source, okay, and we are having the resistance, and we are having two measuring instrument. One is voltmeter, one is ammeter. So voltmeter connected parallel in a circuit always, and ammeter is connected in series in a circuit. So what is the role of ammeter? Ammeter is measuring the current. That's why it will be in the series in a circuit. Okay, and the voltmeter, it's measuring the the potential drop in a particular point. So this will be in a series. Now this voltmeter ammeter, basically they are the galvanometers. So this device is will show some reading when currents are flowing through it, right? Now, inside the ammeter and inside the voltmeter, there is galvanometer, okay, and with some for voltmeter one galvanometer, ammeter one galvanometer, but that's a different architecture inside, okay. That is not part of your scope, but you must remember ammeter will be connected in series in a circuit, voltmeter will be connected in parallel to a circuit. So what is the role of voltmeter? To measure the voltage drop across the resistance. Okay. Now, so this is the circuit and this is the voltage source. This is the positive terminal at the negative terminal. Okay. So current will flow from positive terminal to negative terminal. Right. This is the basic structures. Now, what are the things you have to get ready? First of all, what is charge? Then what is current? Then Ohm's law, what is resistance, internal mechanism of resistance, then the what is EMF, what is terminal voltage, what is internal resistance, then the parallel and series circuit. This is all about these chapters. Okay. Now, so you have to revise the chapter. So first you are studying the books, and also sometimes you are revising mentally, right? Suppose you are sitting in a chair, or you just want to recall the things without seeing the books. So how, let me help you how you are going to recall. Okay, just the chapter is electricity. It started with the electron. Okay, so let me draw a flow chart for you. So this is a part of revision, then I'll again come back to the concept part. Okay, so this chapter starting with the charge, positive charge and negative charge. So negative charge is electron. Which one is moving? Electron. Positive charge not able to move. Okay. Now, next is flow of charge. So flow of charge is current. So charge was Q. If I am having, so current will be charge by time. If I am having N charge, so Q will be N E. So E is the charge of one electron. If I am having n number of electron in a conductor, now what is conductor? So let us draw an image of conductor. So these are the free electron inside the conductor, inside the conductors. So they are flowing. When they are flowing, when we are applying a potential difference, or when we are completing a circuit, we are having a voltage difference, the electrons will move. Electrons will move for this potential difference. Okay. Now, if I am having n number of electron in a conductor, so total charge will be Q is equal to Na. So current will be rate of flow of charge, rate of flow of charge. So Q by T. This is the current. Now, what are the units? So units of current is ampere. Now, the smaller unit is milliampere and microampere. So milliampere means 10 to the power minus 3 ampere. So these are very important. These are very important when you are revising the chapter. Go like this, okay? And microampere means 10 to the power minus 6 ampere. Right. So this is about the current. Now currents are flowing. Now what actually happening? Electrons are flowing, as you all know, and the positive charges are not moving. Okay. Now, so ideally, now the next question is what is drift velocity? What is what is the what actually happening? So actually, electrons are having the collisions. Electrons are having the collisions. So whenever we are saying the collision, now so collisions means that is the cause of resistance, right? Now, so next part is what is resistance? Resistance, what we are going to say? Resistance is the obstacle offered, by the charges, obstacle offered by the conductor. Let's there are conductor, there are electron. So what happened? That these electrons having the collisions with the other electron and also with the positive charges or atoms. There is a collisions. So electrons are in motion. So collision happen. What happened? Their velocity got reduced. Once the velocity reduced, again they will start moving with acceleration, and this acceleration is coming due to the potential difference. They are in a circuit, so they are getting electric field and they are moving, accelerating. Again they are getting colliding with the other electrons and charges, right? So again, so this way electrons velocity is getting reduced, and finally electrons are getting a drift velocity. Drift velocity, drift velocity, and which is helping it to move. So now again let me draw the circuit. In the circuit, this is the resistance. So now what we understand, this is a negative pole, positive pole. So electron will move like this from negative terminal to positive terminal. Why? Because negative terminal is having the repulsion and they are moving like this. Okay. Electrons is trying to reach to the positive terminal in the circuit. So current will flow in the opposite directions. So flow of current is the opposite direction of flow of electron. Due to these reasons, the currents will flow from positive terminal to negative terminal in a circuit. Okay. So this is very important part. Now next is that you are having the resistance details. So what is resistance? This is the obstacle offered in a material like it may be conductor and insulator and the semiconductor and superconductor. So conductor having the large number of free electron. So on that case, when a conductor is in a circuit, so there will be good amount of flow of current. The resistance will be less. And whenever there is a lesser number of free electrons, that is called the non-conductor, so resistance will be higher. And what is the formula of resistance? R is equal to rho L by A. Now A is the area. So whenever you are going through this formula, always write down this, or just during the revision keep it in mind that you have to think like this. This is the part of a conductor this is the area, and this is the length of the conductor. Length of the conductor. So this L is the length. Now the resistance means actually collisions. The collisions, so more collision, more resistance, lesser collision, less resistance. So whenever the areas are more, the collisions possibility will be lesser. Collision possibility will be lesser. So that's why resistance inversely depends with the area of a conductor. And the more the length of the conductor means more number of collision will happen. Okay. So R is proportional to L. R is proportional to L. Okay. Now next is the rho. Rho is the resistivity. This is a very specific to a particular object, right? Like copper, nickel, or a different kind of material having their specific resistivity. Specific resistivity. So this is the rho is the material specific. Rho is the material specific, or it depends on the nature of the material of the conductor. Okay. So this apart from 3, there is the temperature. So with temperature, what happen? That whenever we are increasing the temperature, electrons are getting excited and the collision possibility will be higher. So resistance will be increasing in normal cases. So if, again there is an ohmic and non-ohmic structures that I will discuss later in other classes. Now, and what is the superconductor? Superconductor means where resistance is very low. Resistance is very low. So resistance, whenever we are decreasing the temperature of a conductor, its resistance getting lower, lower, lower. So by very low temperature, conductor will be, the resistance will be very less. So conductivity will be very higher. Okay. So that's a kind of superconductor. Okay. So now this is about the revision of resistance, and what are the units of resistance? It is the ohm, right? Ohm. So we are saying that R is equal to, let's say, 5 ohm, okay, 10 ohm, or you can say 10 ohm. So this is the measuring. Now next is the Ohm's law. So what Ohm's law is saying? So this is the revision class. So I am going like that. So V is equal to IR. So current in a circuit is proportional to the voltage applied on it. So more the current, if in a circuit, if I am increasing the voltage, the current will be increased. Let this is a 10 ohm resistance. If I am applying 10 volt here, what is going to happen? What will be the current? 10 volt. So current I will be V by R. So it will be 1 ampere for this circuit. Now if I am applying 100 volt, what will be the current? 100 volt by 10 ohm, so 10 ampere. So I am increasing the voltage 10 times, my current is increasing 10 times. Okay, that means the ratio, the V by I ratio, this is constant for a circuit, for a particular material. Okay, so this V by I, so this is constant for a particular resistance, Okay. Now, so this is about the Ohm law. So V by I ratio. Now there is a concept called slope. So slope will be the constant. Now let me show you what is slope. So for this circuit, okay, in x-axis if you are taking the voltage, in y-axis if you are taking the current. Let's say this is a straight line. Okay, so what will happen? The straight line, if I am taking theta here, so it will be change in current like reading of delta I by delta V. So slope of this graph will be is equal to tan theta will be is equal to height by base or perpendicular by base. So delta I by delta V. Okay. So this is the resistance. This is the resistance. So this is the graphical nature for ohmic resistance. Okay, ohmic. So there are ohmic and non-ohmic nature. So we are discussing about the ohmic here. So ohmic means they will follow the Ohm's law, and this graph V by R is showing a straight line, and the slope of the straight line delta I by delta R is presenting the resistance. That's why V is equal to IR or R is equal to V by I. So keeping the resistance constant in a circuit, if you are varying the voltage, you will get the variable current. Okay, this is one part of your chapter. So your revision is going on, right? So you understand resistance, and you know that units of resistance, ohm, units of voltage is volt, current is I am ampere. Now what is voltmeter? You know that it is connected in series. What is ammeter? Voltmeter connected in the parallel circuit and ammeter connected in series. Now let me show you one more circuit now, which will help you to understand about the series and parallel. Okay, so let's say this is R1, this is R2, this is R3, this is the voltage drop V, this is the voltage in the circuit. Now current will flow in this direction. So what are the voltage drop here? Here voltage drop will be V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. So what happened in this circuit? The current is fixed. The fixed current I is going for all the resistance. Same current is flowing. There is no change in current for this circuit. Same current will flow. This is very important. This is a series circuit. Series. Same current will flow in this circuit in all resistance. So what is the going to change? So total voltage is the summation of the all three voltage drop. V is equal to V1, V2, V3. So this is V1, this is V2, this is V3. Okay. So for a series circuit, current is fixed. The voltage is getting divided in V1, V2, V3 for different resistance. These are the called voltage drop. So V is equal to summation of V1, V2, V3. Now V is equal to IR. R is the total resistance of the circuit, the equivalent resistance. Current is fixed. Now V1 is equal to I R1, V2 is equal to I R2, V3 is equal to I R3. That means we are getting the voltage component for all the different resistance V1, V2, V3. Now, if we equalize, the V is equal to V1, V2, V3. So, V is equal to, let me write here, I hope you can able to see. So, this V is equal to V1, V2, V3. So, I will replace this with the IR. So, main voltage V is equal to current I, R is the equivalent resistance of the circuit, IR is equal to IR1 plus IR2 plus IR3. So, we are getting R is equal to R1 plus R2 plus R3. So, this is the formula of the series resistance. Okay. In the next session, in the next revision class, I will come with the parallel and the few numerical, for practice for this chapter. So, this is the series, and what about the parallel? Parallel will be 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. In series, the equivalent resistance is higher than any of the individual resistance, but in parallel, the equivalent resistance is lower than any one of the resistance. That means R parallel is the equivalent, which is lesser than R1. R parallel is the lesser than R2. R parallel is lesser than R3. So this way you can backtrack your solutions, that if you are in correct set or not. In series, it will be addition. In parallel, it will be like this. Okay. So that's it for today's session. In the next session, I will again come the part 2 of the revision of this chapter. Okay. Please go through it. Any doubts, any questions, please reach me through this YouTube channel. I will respond to you definitely. Okay. So we are having a dedicated sessions for you for the class 10 ICSE. If anyone has any doubts in any chapter of this, please WhatsApp me and our numbers in our Academy channel. Okay, so welcome to Chatterjee Academy. Please watch, and if you like it, please subscribe. Okay, thank you.